Hi everyone. So let's look at this first proposition, which of course is valid for all the three conics, parabola, ellipse, hyperbola simultaneously. If the line produced if necessary joining the 2 points P and Q of a conic meet the directrix in F. So what I do is I take this as a conic. This can be a parabola, maybe this turns out to be an ellipse or hyperbola. And I take a line which meets the conic at two distinct points P and Q and meets the directrix in F. The point here is that produced if necessary makes sense if it was a hyperbola and the chord was drawn on two different points on two different branches of the hyperbola, then you need not probably produce the segment to meet it at F. If I take this point as S be the corresponding focus, because when there are two directrices and two foci, then we have corresponding focus. Then we have to prove that SF, as in this segment, would bisect the angle PSQ between SP and SQ internally or externally. So if I extend this, so what probably they mean to say is SF will bisect this angle. That means these two angles should be same. To prove this, what we will do is we will use elementary class 9th geometry, and that is the whole beauty of this assignment. So I drop two perpendiculars from P and Q onto the directrix and let the foot of perpendicular be respectively M and N. So by the definition of conic, we know that PS upon PM is equal to QS upon QN, is so to say the eccentricity, which can be one for a parabola, something bigger than one for a hyperbola, lesser than one for an ellipse, but they remain to be the same E. Also, if I look at this point of time, these two triangles, triangle QNF and triangle PMF, they both are similar, which definitely implies that the ratio of their hypotenuse, that is PF to the ratio of the perpendiculars PM, should be equal to QF is to QN. Now if I rearrange the first equation that we got, then I get PS upon QS is equal to PM upon QN. I just swap this cross multiplication. Likewise, if I do here, I get PF upon QF is equal to PM upon Qn, and then I see that Pm and Qn are the connecting link ratio in both of them. So this implies that PS upon Qs is equal to PF upon QF. Now have a look at triangle PSQ. F is a point on extended PQ such that PF is to QF, that is ratio in which the point this Fs side cuts the opposite side in an external ratio is the ratio of sides containing the angle. So this is sufficient to say that Fs is the external angle bisector, and we get a result.